All right. Hey, everybody. We are either doing this problem tomorrow or we did it today based upon where our lab day has fallen. But it's a great problem for looking at where we need to be with analyzing balanced forces. In this case, we've got three dogs fighting over a chew toy in such a way that the chew toy remains at rest. That is a big idea for me and tells me the acceleration is 0. The chart below describes the forces exerted by the Dalmatian right here and Chili the dog right here. And this is our golden retriever, which we don't know how big this force is, the magnitude, or what direction it's pulling. It says draw a picture of the forces acting on the chew toy and to ignore the force of gravity, which would be going like into the page. I already got started drawing Chili and force of the Dalmatian right there. And I made the Dalmatian one a little bigger because this force is a little stronger, pulling with 80 newtons as opposed to Chili's just 25 newtons. The golden retriever on this picture looks like it's pulling this way. And I can kind of draw it like that, and I'll label that F sub G. Part B says, what's the acceleration of the toy? Well, I already figured that out. A equals 0. And what that means is that it has balanced forces. A different way I can write that is I can say the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0. That is true. This ring doesn't accelerate because there's just as much pulling left as there is pulling right, and there's just as much pulling up as there is pulling down. So looking at part C, that actually leads me to figure out the magnitude and the direction of the golden retriever's force, because in part A, we made what's called a force diagram. But now, to look at this one, we're going to do a component diagram. Whichever class you've seen us work with component diagrams already. The idea is you're taking all your forces and drawing what's a horizontal force and what is a vertical force. Meaning, like, the force of the Dalmatian is pulling straight up, and I care about that because I'm going to actually care about what's happening horizontally and what's happening vertically in this problem. Chili is pulling to the left. But the golden retriever's force doesn't fit on either the x or the y, so I actually need to do both. The golden retriever is pulling down and to the right. So I need to draw the fact that the golden retriever is pulling down and to the right. Turns out these two forces are balanced. The force of the Dalmatian is pulling up is equal to the force the golden retriever is pulling down. And the force that Chili's pulling left is the same as the force that the golden retriever is pulling to the right. The golden retriever has two jobs. It has to not only stop what the Dalmatian is doing, but also what Chili is doing. And that's why this toy remains at rest. So if I want to figure out how big the force is, I have to realize that, okay, the Dalmatian's pulling with 80 newtons upward. That's what that 90 degrees just tells me. And Chili is pulling with 25 newtons to the left. Well, that means the golden retriever has to be pulling with 80 newtons down and 25 newtons to the right. To figure out just how big that is and to combine them, I can make it kind of look like a triangle and say 25 newtons to the left, 80 newtons down. If I made it look like the original vector, I see that right in here, I can combine these using Pythagorean theorem and end up getting 83.8 newtons. That's just a squared plus b squared equals c squared. Goodness. And I can put that right in here for the magnitude, 83.8 newtons. For, like, give or take a few points, like, if that's rounded or not. Now we need the direction. Well, here's the deal with the direction. I'll actually draw it up here on the dogs. This is 0 degrees right here. This is 90 degrees up here. This is 180 degrees over where Chili is, and down here is 270 degrees. The golden retriever's pulling in quadrant 4, so the answer has to be something between 270 and 360 degrees. That's the only way that this is going to make sense, that if the golden retriever is pulling in quadrant 4. That's how you cancel out Chili and cancel out the Dalmatian. And we already predicted that this would just be in quadrant 4 because we drew it down and to the right, and that's what that means on the unit circle. So the angle I'm actually looking for is this. And there's a few ways that different people can find it. Some people like to find this angle and subtract that angle from 360. Some people like to find out what this angle is and then add it to 270 degrees, which is like what this is just up till there. So I'm going to do that right now. And to find out what this is, I can make this look like a triangle and make this side 25 newtons. And so figuring out that angle is a little math class stuff. I can do the inverse tan of 25 over 80. If you like inverse cosine or inverse sine, just do that and use your hypotenuse. That's going to equal to theta. Let me grab my calculator. Let me double check on that hypotenuse too. I was just remembering from doing it earlier in the day. Yeah, 83.8. And then make sure I'm in degrees. And I want to do the inverse tan of 25 over 80. A reminder, this is not our answer, this 17.35 degrees. Always recognize in physics when your calculator isn't giving you an answer, but giving you something that leads to an answer. What we actually want is 270 plus 17.35, or 287.35 degrees. That is the thing that's in the fourth quadrant. That's between 270 and 360 degrees. And what's nice is it's actually less than 315 degrees, which actually is directly between those two, because the golden retriever has to pull more down than it does to the right. So this one should be closer to 270 than it is to 360 degrees. And that's just working through the dog problem. Make sure that you can solve a similar problem by combining two forces in the x and the y into one force, just like we did here for the golden retriever.